Hi folks, we're going to take a look at number 8 from page 408. So here we've got a computer with an initial value of $2,000 and this models its value over time. Now notice here this base of 1/2, essentially it's a half-life problem except for the value of a computer instead of what we usually see it as for a radioactivity problem. Okay, so here they give us some information. They say after 1 year, the computer has a value of $1,516, and they want us to determine what the half-life of the value is. Okay, so not surprisingly here, this H in the equation represents the half-life, which is what we're dividing the time measure by. Okay, and then they're asking us how long it would take for the computer to be worth 10% of its purchase price. All right, so let's see how we can solve this problem. So I've got the equation already here. So let's input the information that we know. So we know that after a year, the final value is going to be 1516. All right. Of course, our initial value is 2000. All right. And this change in value occurs over 1 year. So t is going to be equal to 1. And the only thing left in our equation is h, which represents the half-life. That is the amount of time it takes for the value to go down by half. All right, so here we're just going to solve. I'll divide both sides by 2000, so 1516 over 2000. I'm not going to bother even calculating that since I'm going to use my calculator later on. Equals 1/2 to the 1 over h. And here, in order to get this variable out of the exponent, I'm going to take the logarithm of both sides. And since I'm going to be looking for an approximation, I'm going to take log base 10. So I've got log base 10 of 1516 over 2000 equals log base 10 of the right-hand side. Well, we know I'm going to use the ski slope rule to bring down that 1 over h. So I'll just do that all in one step. All right, and now I can solve for h. I'll just multiply it to the other side of the equation. And here I'm going to divide by this number on the other side. So I'm just left with log of 1/2 divided by log of 1516 over 2000. Okay, so here, keeping the numbers exact up until the end also helps me get a more accurate answer. So I'm not making approximations at every step. Okay, so let's put that in here. So here we've got log of 0.5 divided by log of 1516 divided by 2000. Okay, and it looks like we've got about 2.5. Okay, so the half-life is about 2.5 years. So every 2.5 years, the value of the computer goes down by half. Not sure how reasonable that is, but that's what the problem gives us. So let's take a look at B. So this was the answer for A. Okay, so if we take a look at B up here, it says how long will it take for the computer to be worth 10% of its purchase price? Okay, so 10% of 2,000 is just going to be $200. Okay, so my final value here now will be $200 with, of course, my 2,000. And now I know that my half-life is 2.5 years, and I want to determine how long it takes to get to 200. Okay, so yet again, I have a very similar type of equation as I had there. So I'll divide this to the other side, so it's going to give me 0.1. Okay, 0.5 to the t over 2.5. And again, I'll take log base 10 since I'm going to want to approximate anyways. So this is log of 0.1. Here, when I take the logarithm of the right-hand side, again, I'm going to apply the ski slope rule right away. So t over 2.5 times log of 0.5. And now I can just solve for t by multiplying by 2.5 and divided by log of 0.5. So 2.5 times log of 0.1 over log of 0.5. All right, and let's see what we get. Okay, so we've got 2.5 times log of 0.1. All right, and that's divided by log of 0.5, and that's about 8.3. So the time it takes is about 8.3 years in order to get to 10% of the original value. So again, I'm not sure how reasonable that is for a computer. I would think it would get down to that value even sooner than that. All right. So just to recap here, what was nice about this problem is they gave us the equation for us, but it was a matter of interpreting what each of these variables represented. And in both cases, I was able to solve these exponential equations just using simple logarithm Bates-10. Okay, that's it for this one.